Understanding wind turbine axes.
Wind turbines convert wind energy into electricity. They come in two main types, defined by the orientation of their main shaft: horizontal axis wind turbines, or HAWTs, and vertical axis wind turbines, known as VAWTs. These designs work differently, and each has specific advantages and disadvantages based on how they interact with the wind.
Horizontal axis wind turbines, HAWTs.
The horizontal axis wind turbines have blades that rotate around a horizontal shaft, similar to a traditional windmill. They need to face into the wind, using a mechanism to turn the blades accordingly. HAWs are the most common type found in large-scale wind farms because they are very efficient at generating power when the wind blows steadily from one direction.
Vertical axis wind turbines, VAWTs.
Vertical axis wind turbines have blades that rotate around a vertical shaft. A key advantage is they can harness wind from any direction without needing to reorient, making them useful for turbulent or shifting wind environments. VAWTs are often selected for urban or small-scale applications, although they generally produce less energy than HAWTs.
Installation and maintenance differences.
HAWTs typically require taller towers and complex mechanisms to align with the wind, which can make installation and maintenance more challenging and costly. In contrast, VAWTs have simpler designs and lower centers of gravity, allowing them to be placed closer to the ground for easier access. However, VAWTs may experience more wear due to uneven wind forces.
Efficiency in applications.
The HAWTs are more efficient for large-scale electricity production and are preferred for open, windy areas. VAWTs excel in environments where wind direction changes frequently or space is limited. The choice between the two depends on the intended use, available space, wind conditions, and budget. Both designs play important roles in harnessing renewable wind energy.